In this video, we're going to focus more on the writing aspect of systems of equations. So by the end of this video, you should be able to write systems of equations from word problems. Again, we want to make sure that we're successful here because when we start solving them, we want to make sure that we know how to write them correctly. Again, many real-life situations can be modeled using linear equations. Remember that when two or more equations are used, it's called a systems of equations. And if all the equations are linear, then it's called a linear systems. Systems of equations are helpful for us. It can help you figure out the time it would take to equal something. It can help with cost analysis when you're talking about two different options, such as what taxi service to use or what phone company to use. So systems of equations can be useful for a lot of different things. When we're writing systems from word problems, we're identifying the two variables first, so you need to look at what it is that you're trying to find. Then you're going to write two equations, and then once you've written the two equations, that's when you can begin to solve them using one of the three methods for solving systems. We have some clues for when to write from standard form. This is when you're given two different quantities, such as adult and children. Once you identify those two quantities from that word problem, then look for the value of each one. So there should be a value, there should be a number attached, usually it's price, attached to each of those quantities. So you want to make sure that you're good, that you identified those. Find the two totals. So there's going to be two totals in there as well. And then you're going to write the two equations, one for the total and one for the value. So one for the total quantity, one for the total value. When we're writing from slope-intercept form, because there are certain cases we're writing from slope-intercept form, the clues that you want to look for are, is there anything that indicates a rate of change? Okay, are there words like per or something? Is there an initial value that would represent a y-intercept or a one-time phi? It's going to be a huge clue for you that the equation should be written in slope-intercept form. Once you've identified those two things, then you're going to write both equations or the two equations that you have in slope-intercept form, and then again you can solve them from there. Let's look at the following example. Tony had to decide between two gym memberships. Lifetime Fitness had a one-time initiation fee of $50 and a monthly fee of $20. So I'm going to stop here. This is giving me a clue right here that this is going to be written in slope-intercept form. I have a one-time fee, that would be my y-intercept, and I have a monthly fee, that would be my slope. So one of my equations is going to be y equals 20x plus 50. Then it talks about Fitness 19. Fitness 19 was just $30 per month. So no one-time fee there, but there is a rate of change, which is 30x. Now, I need to be able to define these variables, so I need to know what x is, and I need to know what y is. I want to clarify that x is not Lifetime Fitness, and y is not Fitness 19. We look back at the problem. So how did I get this 20x? Well, we know that we have a monthly fee of $20. So this $20 is charged per month. So x would have to be the number of months. And then if x is the number of months, right, $20 times the number of months plus another $50, that would give me my total cost. So y would have to be total cost. So make sure that whatever variables you put there make sense in that problem. All right? Okay, so he determined that if they were the same at 5 months and $150. So you want to check this. 5 months, $150. Okay, well this gives me a clue that my variables were right, because months was x and dollars, which is cost, was y, so we're good there. But I want to check it in both equations just to make sure that we wrote the equations correctly. So remember that when we're checking, we're plugging in those points. So 150 equals 20 times 5 plus 50. 20 times 5 is 100. 100 plus 50. Does 100 plus 50 equal 150? It does. So because we have the same thing on both sides, we're good to go here. Looking at the next one, 150 goes in for y, right? 5 goes in for x. 30 times 5 is 150. 150 equals 150, so we're good there. Let's look at example number 2. In your piggy bank, you have a total of 35 coins, only dimes and nickels. The total is $2.50. So I don't have a rate of change here, so that's a clue that these are probably going to be written in standard form. My two items, my two quantities here are dimes and nickels. So I'm going to let X be the number of dimes, because I know the value of a dime. We're going to let Y equal the number of nickels. And we want to be pretty specific. Now I have two quantities. Notice I have 35 as one of my quantities. I have $2.50 as my second quantity. And so we know that there's 35 total coins. So the number of dimes plus the number of nickels, so the number of dimes X plus the number of nickels Y, has to equal a total of 35 coins. So X plus Y equals 35. We know that the total value is $2.50. So how could I figure out how much worth of dimes I have? Well, if a dime is worth 10 cents, that's 0.10. X plus a nickel is worth 5 cents, so 0.05. Y will give me a total of $2.50. Now, after counting, he determined there were 20 nickels and 15 dimes. Check the solution in both equations. So we want to check it in both. So I have X plus Y equals 35. So X was the number of dimes, so 15 dimes plus 20 nickels equals 35. So 15 plus 20, that does equal 35. So I know that this first equation was correct. 0.10 times the number of dimes, so 15, plus 0.05 times the number of nickels, that's 20, equals $2.50. Well, 0.10 times 15, that's 1.5. 0.05 times 20, that's 1. And 1.5 plus 1 does equal 250. And so we're good there. So I know that both of my equations we wrote are correct. Now we're giving you the solution here so that you can check to make sure that the two equations that you wrote were correct. So that when we get to problems where you're having to solve and find the solution, you don't have to worry about if you wrote the equations correctly. Looking at 3, it says the perimeter of the triangle is 46, okay, or 46 inches. The base of the triangle is 4 inches longer than the length of one of the other sides. So they give us two variables here. They give us X, they give us Y. So X would be the length of one of the sides. And Y would be the length of the base. Now, one of these equations is going to be written in standard form, and one of these is going to be written in slope-intercept form. I know the perimeter of this triangle is 46 inches. Well, I know that in order to find perimeter, we add all of the sides. So I'd have to add X plus X, which would give me 2X, plus Y, and that would give me my perimeter of 46 inches. So my first equation is going to be 2X plus Y equals 46. Again, that's X plus X. So this X plus this X gives me 2X plus another Y is equal to 46. Now we know the base of the triangle, the base is Y, is my equal sign, 4 inches longer than the length of one of the other sides. Well, the length of one side is considered X, and 4 inches longer than that, that would be X plus 4. So those are my two equations. It says the sides of the base, the sides are 14, and the base is 18. So I know that each side is 14, and I know the base is 18. So if we check this solution, that's going to be 2 times 14, because each side is 14, plus 18, because that's the length of the base, should equal 46. Well, 2 times 14, that's 28. 28 plus 18 is indeed 46. So because both are 46, we are good to go there. Okay, let's look at another one. So we have, let's check our next one. So we have 18 is y, and then 14 plus 4, because 14 was x. 14 plus 4 is 18, so 18 does equal 18, so we're also good with this one. Okay, we have at the end of the 2000 baseball season, the Cincinnati Reds and the New York Yankees had won a total of 31 games. Okay, I have two quantities here, New York Yankees and Cincinnati Reds. So my two variables are going to be Cincinnati Reds. So there's my two quantities. And New York Yankees. And it's going to be their games won, so we'll just say wins. Because it said they had won a total of 31 games. So I know my first equation has to be x plus y, the number of Cincinnati wins, plus the number of Yankee wins, is equal to 31 total wins. The Yankees had won 5.2 times as many World Series as the Reds. So the Yankees were y, had won 5.2 times as many. So 5.2 times the number of Reds wins. So that would be x. Again, the Yankees had a total of 26. The Reds had a total of 5. So we're going to check it. Again, 5 goes with x, because that's Reds. 26 goes with y. That's Yankees. 5 plus 26 is 31. So we know the first equation is correct. 26 is y. 5 was x. 5.2. 5.2 times 5 is 26. So 26 equals 26. So we know both of our equations are correct. Okay, our last one. We have supplementary angles are two angles whose measures add up to a sum of 180. So we have a total here. So I know one of my equations is going to be in standard form. Defining the variables, I have two angles. We're going to say measure of angle 1 will be x. And y would be the measure of angle 2. All right, for writing two equations, our first equation would have to be x, the measure of angle 1, plus y, the measure of angle 2, is equal to 180 degrees, because it says that x and y are supplementary. The measure of angle x, so x, is 24 degrees greater than the measure of angle y. So if I take the measure of angle y and I add 24 to it, I'll have the measure of angle x. And so those are my two equations. We'll check them. So it says angle x is 102, angle y is 78. Okay, so 102 plus 78, if I plug it into my first equation, should equal 180, and it does. X was 108, or 102. Y was 74, or was, 78. Is 78 plus 24 102? And it is. So we know that both of our equations here are correct. Before watching the next video, please consider the following. What would your strategy be for solving a word problem?